Alright, so here we are with Unit 12, Lesson number 5, and we're going to talk about, now that we finished up the types of natural transmutation, we're going to look at the types of artificial transmutation, and we are going to start with fission. First, let's just quickly run through what do we mean by artificial transmutation. Well, artificial transmutation means you take an element that is not radioactive. In other words, its nucleus is stable, and for whatever reason, and you're going to see why in a minute, we bombard the nucleus with particles. It could be a neutron, it could be an alpha particle, etc. That forces the once stable isotope or nucleus to now become unstable, which will then force it to give off particles, not necessarily the same particles that it absorbed. The one they ask about the most is nuclear fission for a couple of reasons. One, nuclear fission is a process by which we produce energy, electricity, in nuclear power plants, and it's not produced as a direct result of the fission, and we can quickly run through that. So you do need to know the definition for fission. It's when you basically are taking a large nucleus and splitting it into two smaller pieces. Those smaller pieces are not necessarily equal in size. And here's a good diagram of what occurs during fission. Here's our target nucleus. This is our nucleus that we are going to bombard with a neutron. When this nucleus absorbs this neutron, it's going to undergo fission. And when an atom's nucleus undergoes fission, it produces three things. It produces energy, and a tremendous amount of energy, which is represented by this, and it breaks apart into two smaller pieces. In this particular case, it breaks apart into a barium atom and a krypton atom, and it gives off three additional neutrons. And those three neutrons could then hit three other atoms and continue the process. And this is again just going through just from a different perspective. One of the disadvantages of nuclear fission in power plants is that there is a problem with two things. Water is used to cool the plant so it doesn't overheat, and that water then becomes so hot that you can't just then release it into a river or the ocean, because that is called thermal pollution. So you first have to cool that water off, and then you can release it. The other advantage, which is worse, is that you end up with, over a period of time, nuclear power plants that have been exposed to so much radiation that after a certain period of time, 30 years or so, those nuclear power plants have to be decommissioned and taken apart because they are so high in radioactivity, and you can't just put them in a dump. So you have to dispose of them in a specific way. You also have spent fuel rods that are no longer being used, but they're still radioactive. You have to have some place to dispose of that nuclear waste, and you can't just put it in a dump. It has to be disposed of properly, and one of the problems we have is that we really did have a place to dispose of it, but that place has now been closed down. So I'm assuming that nuclear power plants are now storing their radioactive waste actually in the power plant, but at some point they're going to have to get rid of it. So that's the main disadvantage of fission, is that it produces nuclear or contaminated radioactive material. An advantage of it is that we have a lot of fuel for it, and you get a lot of bang for your buck. In essence, you need very little amount of uranium to produce a large amount of energy. The next type of artificial transmutation is called nuclear fusion. And in one way, it's the exact opposite of fission. In nuclear fusion, what you're doing is you're taking two small nuclei, usually hydrogen atoms, and you're combining them together at a very high temperature, and they make a bigger molecule, a bigger nucleus. And when they do that, they also give off a tremendous amount of energy, similar to fission. And most of the time, and this is just sort of an example of fusion reaction, I think these are probably better. Notice that in every single case, most cases, hydrogens are the reactants. I wouldn't worry about this one here or this one here. The ones in the middle, where you're combining different isotopes of hydrogen to form helium, are the most common ones. So you do need to be able to recognize a fusion reaction from a fission reaction and from an alpha decay or a beta decay or a positron decay. What are the advantages of fusion? Well, the advantages of fusion are a lot. They give off a tremendous amount of energy. There is no nuclear or radioactive waste produced. We would have pretty much an endless source of fuel, which would be hydrogen atoms, which we can get from water. The disadvantage of fusion is that it requires so much energy to actually start the fusion reaction, and it burns at such a high temperature that we haven't been able to develop material strong enough to withstand the heat that's produced. If you have a fusion reaction that's burning at 1,000,000 degrees, we don't really have anything that can contain something of that temperature. It will immediately melt through that. So there is many scientists are working on trying to get fusion to occur at a much lower temperature. Nobody has actually been able to do that as of yet. If they did, our energy problems would be solved. We wouldn't need to worry about oil, coal, or natural gas because we could just use fusion, which in essence produces no pollution at all. And those are the two main types of artificial transmutation. One of the things that occurs during artificial transmutations is something called the mass defect. And the reason why these processes produce so much energy is that during the process of fission or fusion, some of the mass of the reactants is converted into energy. So what happens during fission reactions is that the mass of the products is going to be slightly less than the mass of the original reactants. That's not something you need to worry about how to figure that out. You just should be familiar with what's called the mass defect. And that occurs mainly during fission reactions. And that's it for this section.